Hello and welcome to the walking talking topic on simultaneous equations. Question number 5 with me, Mr. Barton. Now this is our final question on simultaneous equations, so let's end with a weird one. All kinds of funny pictures going on here. Let's see what's happening. Catherine and Susie both have necklaces with chunky beads. They notice they have the same types of beads but different numbers of each bead. I love these math situations. The beads are either cubes or square-based pyramids. All the cubes are identical. All the square-based pyramids are identical. The girls both take off their beads of their necklace and place them in straight lines. So there's Catherine's and there's Susie's. Calculate the length of the edge of the base of a pyramid and of a cube. Now, why Catherine and Susie couldn't just measure these for you, seeing as they're measuring the whole necklace, God only knows. But anyway, they're being awkward, so let's sort it out for them. Now, this is simultaneous equations in disguise, and the way to spot it is you've got two things you don't know. You don't know the length of a cube, you don't know the length of a pyramid, but you've got two equations, two pieces of information to help you get it. So let's set this up. Let's take Catherine's first. So she has got 4 cubes. So I'm going to put 4c, where c is going to stand for the length of one of these cubes. And she's got 5 pyramids, where p is going to stand for the length of one of these pyramids. And when you add those together, the length comes to 38.8 centimeters. Susie, she's only got 2 cubes per thing, but she's got 7 pyramids. And that in total comes to 35.6. Now I'm just going to double check that I have added these up right, because if I mess this up, it's all going to go wrong. So there should be 9 things in Catherine's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice. Susie should have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Okay, so classic simultaneous equations. Easiest thing to do here is to probably make the number of cubes the same here, because Susie's got 2, so we can double up everything here and get 4. So what I'm going to do is I'm going to label them equation 1 and 2. I'm just going to write equation 1 out again. I always like to do this, just so I've got it nicely lined up there. And I'm going to take equation 2 and I'm going to times it by 2. And that's going to give me, instead of 2c, I'm going to have 4c's. Instead of 7p, I'm going to have 14p. And instead of 35.6, flipping heck, double 35 is 70. Double 0.6 is 1.2, so 71.2. You've got to be good with your decimals with these ones. Put a box around the letter you've made the same. So that's my cubes in this case. What signs in front of them? Well, they're both positive. The signs are the same, subtract. So I'm going to subtract one from the other. And I'm going to use my technique again. I don't want dodgy negatives. I don't want to do 5p take 14p. So I'm going to do 14p take 5p. I'm going to consistently do the bottom subtract the top. So 14p take 5p is going to leave me with 9p. And then, now I'm going to write this out. 71.2 take off 38.8. Okay, 2 take 8 is not happening. Borrow 1 from him. That's 12. 12 take 8 is going to be 4. Fine. 0 take 8, not happening. Borrow 1 off her. Put my 1 there. So 10 take 8 is 2. And 6 take 3 is 3. Notice, even though we are doing fairly tricky GCSE, this technique of adding and subtracting decimals never leaves us. So you've got to be really good at that. And now something else you've got to be good at is dividing. 9p equals 32.4. What does 1p equal? Well, you've no calculator on this one, so we're going to have to do a bit of old-fashioned bus stop. 32.4 divided by 9. Okay, how many times does 9 go into 3? It doesn't. Carry me 3. How many times does 9 go into 32? Well, that's 9, 18, 27. So that's 3 times with a 5 left over. Put me point there. How many times does 9 go into 54? 9, 8, 27, 36, 45, 54. 6 times. So I reckon P is 3.6. So that's the base of the pyramid, 3.6 centimeters. Now we've got to work out the cube, so I'm going to use Susie's from the top here. So she said 2 cubes plus 7 pyramids is going to equal 35.6. I'll tell you what, they're making us work with these decimals here. 2 cubes plus 7 lengths of pyramids, so that's 7 lots of 3.6, should equal 35.6. 7 lots of 3.6, I'm going to have to do that down here as well. So I'm going to go for this technique here, 3.6 times by 7. This is the way I used to do it before grid method or any of that was invented. 7 lots of 6 is 42. Put me 2 down, put me point in, carry me 4. 7 lots of 3 is 21, plus me 4, and that's 25. So I'm going to go for 2c plus 25.2 equals 35.6. I hope this is right. Take 25.2 from both sides. 2c equals 35.6. Take off 25.2. Actually, that's not too bad. That's going to be 10.4. I think that's all right, that one. Divide by 2, so cube is going to be 5.2 centimeters. Now, as I've said all the way through, it's up to you whether you want to gamble on this one. For a start, we've actually got to write our answer. So I'm going to have to put pyramid, because we've made up the P and C, remember. Pyramid is 3.6 centimeters. Cube is going to be 5.2 centimeters. Best way is to check, and to check using one that you haven't used already. So we use Susie's beads to work out the length of a cube. So let's use Catherine's beads to check. So Catherine, she had 4 cubes and she had 5 pyramids, and she had a total length of 38.8. So 4 lots of 5.2 plus 5 lots of 3.6. I'll tell you what, can you forgive me on this one? I've done loads of flipping calculations here. I'm just going to check this on the calculator. 4 lots of 5.2 plus 5 lots of 3.6. Please, please, please equal 38.8. Here it comes. Oh, thank God. 38.8 centimetres. So I'm pretty happy with that as an answer. But just when you think you're finished, what's this? Only part B. Catherine's necklace is 80 centimetres long. How many extra cube beads can she place on her necklace? Right, so Catherine at the moment, she's used up 38.8. So I'll make a note of that. That was from the previous bit, 38.8. So that was the length of Catherine's beads. She's got 80 centimetres to play with. So how much has she got left over? So 80 take off 38.8. This will tell us how much spare necklace she's got. So, a bit of old-fashioned subtraction. Fill in a 0 if you haven't got anything there. 0 take 8 isn't happening. Oh God, flip it hard this. 7 and make that a 10. Borrow off him, make him a 9 and make that a 10. 10 take 8 is 2. Put my decimal point there. Gonna have to borrow off him again, make him a 6, and he's gonna be an 11. 11 take. Oh no, sorry. Oh, I'm losing the plot here. That was a load of rubbish. Right, flipping start that again. Let's take my time. 80.0. 38.8. That was a deliberate mistake just to show you that you shouldn't rush. Borrow one off him. 7. 1 there. So the 1 that's going to go to 10. Take 1 off the 10 is going to go to 9, and that's going to go to 10 there. 10 take 8 is 2. Done. 9 take 8 is 1. 7 take 3 is 4. Check that looks about right. 41.2 plus 38.8 equals 80. That's looking good. So she's got 41.2 centimetres spare. How many extra cubic beads can she put on? So how many of these cubic beads can she fit? Well, cubic beads are 5.2. So the question really is, how many times does 5.2 fit into 41.2? Now your best bet here is that's a fairly nasty division to do and you don't have a calculator. So let's just use a bit of an approximation. 8 5s are 40. Can she fit 8 of these beads on? Well, let's just have a look. So it'll be fairly close, I reckon. So if I try timesing it by 8, what do we get here? 8 times 2, 16. Put me dot, carry me 1. 8 times 5 is 40, plus me 1, 41.6. Oh, unlucky. She's just missed out on that one. So I'm going to say 8 beads needs 41.6 centimetres. She doesn't have it, so she can fit 7 beads. She's just missed out on that 8, but she's only missed out by 0.4 centimetres, so she can certainly fit on 7 beads. And that is that.